What would you see if you fell into a black hole? We've all heard about these cosmic phenomena, but do we truly know what happens to you as you approach the event horizon? It's not just the end, it's a whole spectrum of unbelievable phenomena, which can only be explained through the theory of relativity and cosmology. Today, we'll dive into the mysteries of black holes and try to imagine what would happen if you found yourself in their terrifying yet fascinating gravitational field. Let's start.
Before we start, do you know what black hole is?
A black hole is a cosmic object with such a powerful gravitational field that not even light can escape it. It forms when a massive star collapses under its own gravity after the end of its life cycle. At the center of a black hole lies a point called the singularity. This is where matter is compressed to infinite density, and the laws of physics as we know them break down. If we want to know more about black holes, we need to go deeper. Black holes are not just empty voids in space. They have a boundary known as the event horizon. It's the point of no return. Once something crosses this invisible line, it's trapped forever, even light. Think of the event horizon as an invisible barrier. Beyond it, space and time are so distorted that the laws of physics as we know them no longer apply. This makes the event horizon one of the greatest mysteries of the universe. But why are they black? And how are they formed? A black hole forms due to the force of gravity. Look at this massive star. Yes, it's the thing that creates a black hole. But how? The star has fuel made of hydrogen and helium, which it uses in thermonuclear reactions to sustain itself. How these reactions work, I'll explain in the next video. Over its lifetime, the star fuses hydrogen into helium and then, in its later stages, helium into heavier elements like carbon, oxygen, and eventually iron. But when the star runs out of fuel, thermonuclear reactions stop, and the outward pressure that balances gravity disappears. The core of the star, where all the heavy elements like iron are concentrated, collapses under its own gravity because no force can counteract it. This collapse triggers a massive explosion called a supernova, ejecting the outer layers of the star into space. If the remaining core has enough mass, about 2.5 to 3 times the mass of our Sun, it will collapse further, forming a black hole where gravity becomes so strong that not even light can escape. Look at the black hole. What do you see? It looks like just a strange black spot in space, but there's much more to it. The black shape you see is called the event horizon. And here's the question we have asked today. Why does a black hole appear black? To answer this, we need to journey to the deepest part of a black hole, the singularity. We've reached the deepest part of the black hole, the singularity. It is the point where the laws of physics, as we currently understand them, break down. This is the heart of the black hole. Without it, a black hole wouldn't exist. The singularity forms from the collapse of a massive star, but the matter that was once in the star doesn't contribute to the blacked part. Instead, it collapses into an incredibly small point at the center of the black hole, where all the mass is concentrated. Imagine you have a ball. Stretch it down to the size of an atom, and you get the black hole. The singularity itself is the ball. So what exactly is the black's part? It's the black hole's event horizon, the boundary beyond which not even light can escape. Everything in the universe has mass, and our ball has mass too. Even if we shrink it, it still retains its mass, though in a vastly smaller volume. When an object is extremely small but has enormous mass, its gravitational pull becomes so powerful that it can attract anything, even light. Now, here comes one of the main questions. Why does the black hole appear black? As we've discussed, the singularity has an enormous mass that distorts spacetime. This immense gravitational force is so strong that even light cannot escape from it. Black is the color of empty space, devoid of light. Since light can't escape the black hole due to its intense gravity, the black hole appears black. What is spaghettification? As you approach the black hole, you encounter one of the most bizarre phenomena in the universe: spaghettification. This is a process where the extreme gravitational forces of the black hole stretch and compress objects into long, thin shapes, just like spaghetti. Here's how it works. The gravity near a black hole is so intense and uneven that the force pulling on the part of your body closer to the black hole is significantly stronger than the force on the part farther away. This difference in gravitational pull is called a tidal force. For example, if an astronaut were falling feet first toward a black hole, the gravitational pull on their feet would be much stronger than on their head. As a result, they would be stretched vertically and compressed horizontally, creating the spaghetti effect. But don't worry, this happens only near extremely massive black holes, and it's an entirely theoretical scenario. No one has ever gotten close enough to a black hole to experience it. And probably we never will. Can you imagine a world where time, as you know it, ceases to exist? What if 1 second for you is a billion years for the universe around you? This is exactly what happens when you approach a black hole. Imagine the clock that falling into black hole, you will see that time is stopped. Black holes are not only places where gravity is so strong that even light can't escape, but also regions where time behaves differently than we expect. According to Einstein's theory of relativity, the stronger the gravitational pull, the slower time passes. As an object approaches a black hole, time for it slows down compared to an observer far away from the black hole. For a person falling into a black hole, time moves normally for them, but from the perspective of an external observer, it seems like the person is slowing down as they near the event horizon. This phenomenon is called gravitational time dilation. You can imagine it this way: when you look at a clock near you, it ticks normally. But the clock near a black hole appears to freeze or move incredibly slowly. The stop-time effect becomes even more striking when you consider what time looks like for an outside observer. From that side of the event horizon, it appears as though the process of something falling in takes forever. This is because the black hole's gravitational field is so strong that it distorts not just space, but time itself. This is one of the most fascinating aspects of black holes. Time, which seems normal to us, actually slows down as you approach a black hole, and it turns out that time changes depending on where you are in the universe. Now that we've uncovered what a black hole is and how it warps space and time, it's time to move on to the ultimate question. What would happen if you fell into a black hole? Could it be more than just an end? Perhaps the beginning of a new parallel reality or a gateway to a mysterious quantum world? Or could it hold answers to questions humanity has yet to dare ask? Imagine standing on the edge of the event horizon. Are you ready to take the plunge into the unknown? Imagine standing near the edge of a black hole, the point of no return. As you fall closer, the universe around you changes in ways you can barely comprehend. Time slows down from the perspective of an outside observer, and you seem frozen at the event horizon. But for you, the journey is anything but calm. First, you'd notice light bending around you, creating a surreal, distorted view of the stars. Colors shift as gravitational forces stretch the wavelengths of light, a phenomenon called gravitational redshift. The black hole appears as a massive, dark sphere with a glowing ring around it, made of light and matter it has pulled in. As you cross the event horizon, the black hole's gravity becomes unstoppable. Spaghettification begins. The part of your body closer to the black hole is stretched, while the part farther away feels less pull. You are drawn into a thin, elongated shape. It's a process that would be terrifyingly quick and intense. Inside the black hole, reality becomes a mystery. You might be crushed by the immense gravity at the singularity, or you could pass into a completely unknown realm. Some theories suggest wormholes or pathways to other universes, but no one truly knows what happens beyond this boundary. Falling into a black hole isn't just a journey into darkness. It's a step into the deepest unknown, where science and imagination meet. Would you dare take the leap? Thank you so much for watching. The universe is full of mysteries, and black holes are just one of them. If you enjoyed this journey, don't forget to subscribe, leave a like, and share your thoughts in the comments. We spent over 20 hours doing this video. What do you want to see next? Stay safe, and I'll see you in the next adventure.